In this video, we are going to look at the difference between C++ objects and Java objects. So let's first take a look at the header file that defines student class. So unlike in Java, we have public and private sections, and similarly with Java, we encapsulate the data member and only expose the behaviors. Okay, so we have the constructor. And take a look at this constructor. We purposely make this in ID as this initial ID with constant char star. That means we don't want to modify the ID here, and the ID passed in. And also we initialize the GPA right here as 0. So that const means we don't want to modify the memory ID points to. And we have a copy constructor here because we have dynamic memory. We have dynamic memory, so it's always a good idea to provide a copy constructor so that when a student object need to be copied, you create a deep copy instead of a shallow copy. And also, when dynamic memory is there inside your objects, it's always a good idea to include a destructor to deallocate that memory before the object dies. Alright, so that's about the copy constructor and the destructor. Whenever you have dynamic memory, you should provide those two. And now let's take a look at the two accessor functions. The accessor function, the first one, the getID one. The getID one, we're returning a constant char star. Remember, a constant char star means we return a constant handle of that ID, which means through that handle you cannot modify the ID. And we have a get GPA. And now let's take a look at those two constant. Those two constant makes the function constant, makes a member function constant. Constant member function means they won't modify the state of the object. That means get ID or get GPA won't modify ID or GPA. So when you design your member functions, if the function doesn't modify the state of the object, you should always put a const there to say, hey, I'm a constant member function. I promise I won't modify the state of the object. We will see why that's important. And the toMutator function just sets the ID and sets the GPA with the passed-in value. And again here, constant char star, that means inside of this function, I'm not going to modify whatever name points to. So that's your promise. But those two are not constant functions. You see, they don't have constant there. They don't have constant here because they're going to modify the state of the object. Now let's take a look at the client of this object, of this class. So let's take a look at the use objects. We first create an object called S1 with initial value here. This S1 is going to be allocated on the stack, on the call stack frame for use object. And now we create another object using the copy constructor of S2. Let's take a look at what did the copy constructor do. So in the copy constructor, we allocate the ID and we string copy. That means we make a deep copy of the ID. So let's come back to this one. So S1 and S2, they have their separate ID, just the ID contains the same G100, but they don't share any memory. So S2 is a deep copy of S1 because we provide that copy constructor to implement that deep copy logic. Now let's take a look at S3. S3 is a pointer to a student object, and we allocated it at runtime. So this object is sitting on the heap. So when you allocate an object at runtime, the object is on the heap instead of on the stack frame. So and take a look at the difference between S1, S2, and S3. S3 is just a pointer, so before we are done with S3, the object S3 point to, we have to deallocate S3. So when we allocate it, we say new. When we deallocate it, we say delete. But for S1 and S2, we are not responsible to release a memory, because remember S1 and S2 live on the stack. So when the lifetime of S1 and S2 is over, the destructor of S1 and S2 get invoked first, then the memory allocated for S1 and S2 get released back to the system. But for S3, we did the new, we have to delete it. So that's the difference between the two different objects, the objects living on the stack and the objects living on the heap. For the object living on the heap, you have to deallocate them. Alright, now let's take a look at this display student. The display student. When we display student S1, we pass in S1. Let's take a look at the signature of display student. Display student take in a student object, so we can pass in S1, we can pass in S2, but we cannot just pass in S3 because S3 is a pointer. We have to dereference the pointer, then pass it in. Alright, so let's take a look at display student. Display student says constant here. Okay, and you're invoking get ID. Remember, I purposely make get ID a constant member function, because if I don't do that, this line won't compile. So take a look at this parameter. The parameter says I'm not going to modify a student. I'm not going to modify that object. But inside of the function, you invoke getID. How does the compiler know getID won't modify a student? So, but we did our part of the job. We make getID constant. That's how we inform the compiler saying, hey, getID won't modify a student object. That's why this line can compile. So you see, you really did your client a favor by putting this getID as constant. This way the client can make a student constant, and when this invocation happens, you won't get compile error. And another indication of student.h here, when you declare it as constant, when you implement it like getID, you see constant, they have to agree with each other. If you leave out constant here, you will have a link error. So you see, inside of this function, we didn't modify ID in any way. So if we try to modify the ID, the compiler will stop us from doing that. It will say, hey, you promise you won't modify the state of the object. So if we try to do something funny about ID here, it won't allow us. And so here in the client code, we can make student object constant, and we can still invoke this function because the compiler will do the checking for us, say, hey, it's a constant member function, you can invoke this one without changing the state of a student object. Alright, so and let's take a look at another thing about getID. GetID says I'm going to return a constant char pointer here. So now let's take a look. When we invoke getID, this getID gives us a constant char pointer, so we have to put it in a constant char pointer variable to do that. And you cannot modify this variable. Try to copy it into something else. It won't compile because it's a constant char star, and if you don't put it in a constant char star, it won't compile either. So that's about the objects in C++ and the objects in Java. So one big difference is when you declare the objects this way, the objects living on the stack. When you create the object this way, the objects live on the heap. And when you create objects this way, you need to remember to deallocate that memory. Thank you.